Yeah, so hello everyone, and we will be beginning with the lecture. But first of all, it is really nice to see these many people turn up for the lecture, and so I hope everybody has been doing whatever questions or resources have been given to you. So first of all, we will take up that. So if you remember, we gave some problems to you to try in the previous lecture. So like these were the patterns given. So just a quick show in the chat. If you have any doubt in any of the patterns or anything you were not able to do, then raise your hand and then we'll ask what is the problem you have. Because from now on, we will be moving to possibly more complex algorithms or more complex code. So it's essential that these basics are clear to you. So if there is any doubt at all in the implementation of any of these, you can raise your hand and we will take that up. Okay, so I don't see any. I'm assuming everybody has done it. If you haven't, no problem. You can, after today's lecture, you can obviously do them. It will be a good exercise for you, and that is why we are saying this again and again. Also, there were these problems that were given to you. So like taking a number as input and then extracting the digits. So anybody had any problem with these problems? Any doubts or anything you were stuck? Okay, Maharsh is saying for the fourth. Fourth, as in this one, reverse the number.
Maharsh, I think you can feel free to unmute yourself and ask your question.
If there's any doubt, you can unmute and ask. So yeah. Okay, and in case you were saying for the fourth one of this, so here what you will do, just like if you have done these problems, you will see कि there are two things you have to maintain, I and j, and according to that you are printing these. So here you will maintain three things. See, you can see कि if you consider this as a square, यहाँ पे there are four spaces, then one star, and then four spaces. So you can consider it like that. So if you have four spaces here, then one star, and then four spaces. Second one, three spaces, three stars, and three spaces. So you can keep a variable that will track the number of stars. And when you have the number of stars, so first में 1, second में 3, then 5, it is easily visible that is 2i plus 1. So you can do like that. So you will get the number of stars. After you get the number of stars, you can calculate the number of spaces very easily, because you know कि अगर if it is a square, then in the last one there will be 2 into n plus 1. So 2 into n plus 1 minus 2 into I plus 1, which will be 2 into n minus I. You will divide it by 2 and you will get n minus I. So at the ith step, there will be n minus I spaces. So now it becomes an easy problem, just like these ones. First print n minus I spaces, then print 2i plus 1 stars, and then again print n minus I spaces. Or you can even leave those spaces, so you're not printing these trailing spaces. So I hope that solves your problem. You can try this. Okay. Whenever you have a pattern, try to express the number of quantities to print in the terms of I, j, n in these things in loop variable. So isse it will become very easy for you to make any type of pattern. Great. So this one was clear, very good. This one, sum of elements of array. This is a fairly trivial one. If you have done this one, then I believe you can do this one here as well. So great. Now we have taken the doubts in the previous problems. Any other doubt you have from the topics or anything else that will take up? Yeah, sorry. So today what we will be doing is we will taking up the standard template library. So what is STL? See, yes, that day we wrote arrays, we wrote some algorithms and so on. But it will happen sometimes that you will not want to write the entire thing yourself, because C++ is a good language. It provides you certain features or some facilities that you can use. So standard template library is such a facility that you have, which C++ gives to you. So in this you have vectors, you have stack, you have list, set, maps. We will look at some of these, and the rest of these will be left to you for exploring, because as and when you will start programming, you will see the use case. If I go and explain everything today, you will not find it useful. So we will be talking about our common ones like vector, pair, tuple. We will talk about these, but the other ones we will leave for now. And I will provide the links for references so you can look from there. Also, this template library not only has the data structures, but it also has the algorithms. So suppose you have an array and you want to sort it. Now, those of you who are familiar key how to sort an array will know you have to write some good length of code if you want to sort an array in a quick time. There are many types of how we can sort an array. We will talk about that as well. But with STL, in one line itself, you can write sort array and the array gets sorted in its place. So that is a very helpful and very quick thing you can use in solving problems, and it reduces your effort. So you can focus more on the logic and more on the implementation rather than writing big chunks of code for sorting an array. And that's it. It also reduces the chance of bugs, because these functions have been executed in the library. So there is no chance that they will have a bug in them. So you will almost have a black box, and you know that that black box is giving the correct output. So there will be very less chance that you will run into a bug yourself. So it is a great medium to use someone else's code, a template which has been already created for your own purpose. So that is why this STL is so important that we are giving a lecture to it. I hope you get it. So the first data structure that we will look at is vector. So vector is a dynamic size. And now what is the meaning of dynamic sized array? If you recall, in the previous lecture, when we talked about arrays, there we said we have to declare an array of n elements. At the beginning, we declare I will need n elements, and that is fixed. In no way you can change the size of an array. You cannot declare an array of n elements. Suppose first you have 10 students in your class. You have made an array for 10 students, but now there is a new admission. So what an array will have to do is you have to create a new array of 11 elements, and you have to copy each and every element again and again, and then add that extra element. So that is a very inefficient process, and we normally try to avoid that. So to avoid that process, we have vector. What is a vector? Vector is a dynamic sized array. So even if you suppose you have declared it initially for 10 variables, but then you want to add 15, you want to add 20, even if you want to add 100, you can easily add in a vector, and the efficiency is very high as compared to an array. So it will not create a new vector again and again. There's a different algorithm behind this, but it will be very much fast as compared to an array. And that is why vectors are used very commonly in computer programming, because first of all, it has many helpful functions. Secondly, it is fast, and then also you can change the size of it. So it is very helpful. And you can also insert the data at the back of the vector. So suppose right now you have a vector. For now, if you want to imagine a vector, you can think it like an array. Matlab, it is an array with some added features. There is nothing in an array that a vector cannot do. Okay. So think about an array. You have a container, and there are some elements stored. Okay. And after that, you will have to, now you have some functions which help you in the process. So जैसे यहाँ पे there is pushback function. So pushback will allow you to push an element to the last. So if you remember, in an array, if you have to push an element to the last, what will you have to do? You will have to write a, then bracket you will have to write the length of a, which is n minus 1 element is this. But in a vector, it can be easily done with the pushback function. It will insert a new element. And suppose you have crossed your limit. So suppose you were initially using 10, but now you want to add an 11th element. So vector has no problem with that. Vector will say ki no problem with this. It will push one more element. So this is where vector gives you some flexibility. Now, since vector is there, you have some other pointers. So begin, end, r begin and r end. So what is a pointer is essentially ki there is a place in memory, okay, where vector is stored. So what will begin will do is it will give you the address of that first position of the first element. Begin will give you the address of the first element. End will give you the address of the last element. So these, you can use this in many ways. So we will look at some ways where we use this, suppose in loops or for iterating through a vector. So that places we use begin, and our begin means key, it will give you the position from the reverse direction. So reverse begin, so it will give you the end element, but it will move in the reverse order. And our end means it will move in the, again it will move in the reverse order. So if you have to iterate from first to last, then you can use begin and end. If you want to iterate from last to first, then you can use r begin and r end. So these are places where these pointers are useful. Don't worry if you don't get it right now. I will write all of this in code and explain to you. There's a size function which will tell you the current number of elements. So because we initially discussed that vector we can add more and more elements as and when needed. So what size will do is it will give you key right now at this instant how many elements are there in the vector. So that you can do. Then resize. Resize is for, suppose you want to resize it. First you had suppose 10 students. Now your class has grown and you know already that you will need 20 students. So you can obviously resize the vector. Although vector does not have a problem if you keep pushing back, that is also completely fine. But sometimes we want to resize the vector, so we can do that as well. So first we will look at how we can initialize a vector. So these are the few processes by which you can do. First is vector entry. This is an empty vector of an int type. So you write the word vector, keyword vector. In this angle bracket, you will write int. Or suppose you want to create a vector of double, then you will write double. If you want a char, then char. Or you can even create a vector of vectors. So if you have worked with array, you might have seen sometimes we use two-dimensional array. We want a grid. Suppose you want a grid, then that in that places we use two-dimensional array. So similarly, you can use a two-dimensional vector as well. So all of these are possible with vector. That is why I said vector offers everything that an array offers, but more. Also, if you want to create an empty vector of size n, so you can do that here. You can even initialize all of the elements at one line as well. So vector int v n, so it will create a vector of size n and initialize each element with -1. So these are very helpful and shorthand notations which save a lot of time and makes the problem easier to solve. So this is how we initialize a vector. Now adding and removing elements. So now let us jump to code for once. Um, just a second. Okay, so we come here. This is another IDE which you can use. So I saw here we have input and output visible simultaneously, so it is helpful at times. So now we will look at how we can create vectors, right? So first of all, we are creating a vector int. Suppose I want to create a vector for 10 elements. So we'll let 10, and I want to initialize each and every one with 0. So what this line will do is it will create a vector with 10 elements and each equal to 0. So each element has the value 0. Now, suppose I want to change the value of the first element to 5. Just an example. So similar to arrays, you can use indices over here. You can use an index. So v0 is equals to 5. So now if I print the value of the first variable, first element of the vector. So there is no input that I need for this one. I will simply run it. So I have got the output as 5. So very trivial. You can, so I'm just showing that it is very similar to an array and you have more functions. So this was one thing that we had. Now the benefit of a vector. So suppose I've created this vector now for 10 elements. Okay. But now I want to add an 11th element. So what can I do? I cannot write v10 is equals to 5. That is wrong. This is wrong because this is an address that does not exist yet. So I will have to use a pushback function. So I will use v.pushback. Okay, v.pushback. Suppose I'm adding an 11th element. So I'm writing 11. So now what will happen is, now the vector is of size 11. Now vector is of size 11, and at the 11th position it has the new element. Okay, so we can try printing this. Cout v10 end line. So v10, if you remember, in a computer the indexing starts from 0. So the 11th element is actually the 10th index. Okay, so let us run this. So we get the 11. But this was not possible with an array. You cannot add a new element after you have created an array. So this is where vector is useful. Okay, so this was one of the functions of vector. We will see more functions now. So as we saw, v dot pushback, it adds the value to the end of the vector. Okay, then there is a function called insert. So insert kya karta hai? You can add an element even in the between. So again, this is one place where it is better than an array. You can insert an element at anywhere in the vector. So you don't need to replace any other element. You can simply insert a new value there. Okay, so let us try this function v dot insert. So I'll just copy it from here itself. And yeah, what does this mean? V dot begin. So as we said earlier, v dot begin gives us a pointer to the first element. Okay, to the beginning of the vector. So what we are saying here is key insert the value 1 at the beginning of the vector. Okay, insert the value 1 at the beginning of the vector. Okay, if you want to add, suppose, to the second place, so I will write v dot begin plus 1. Third place, then v dot begin plus 2. So similarly we can do this. So if I do v dot insert v dot begin 1, and then I print cout v0, because this is the first position. You can recall that initially it was 5. Okay, it was 5. I will print 2 times. So you can see the first one here, v0 should be 5, and here v0 I have inserted a new element, so it should be 1 if there is no error in my code.
Gunjan, for more clarity, maybe we could run a loop to show all the elements, because people might we will not be confused between insert and just replacing an element, right?
Right.
Bhaiya, excuse me, Bhaiya.
Uh-huh.
Bhaiya, the element will be replaced, or that 5 will be present in the address.
Let us see that now only. देखते क्या होता है. We'll create 2 loops, one before inserting and one after inserting. Okay, so this is the first one.
You could comment out the first cout statement.
Oh, okay. Okay, so now we have first created a vector of 10 elements, each has a value 0. We made the first one as 5. So here we should see 10 elements, and the first one should be 5. Yeah.
That end line one should be after for loop, I guess.
That is up to how he wants the output to look, right? The end line just prints a new line. No, it's all right if it's there also.
Okay. Now that it has been said. So let us look at this now. Let me first run it and then I'll explain. Okay, so now I think you can clearly see the difference here, that initially this was in vector of 10 elements and the first one was 5. But now I have inserted 1. So inserting is not equal to replacing. If I wanted to replace, I could have done this. This is replacing. Okay, I'm writing this is replacing, and this is inserting a new value. So none of the other values get changed, only there is a new value that gets inserted. Okay, so now we have 11 elements over here, and the first one is 1. I hope that makes it clear.
Yes, Bhaiya.
Okay, great. Now v dot pop back. So a vector also allows you to remove the last element. So very trivial again, and we will use this function again and again to see what is happening. So suppose I'm doing v dot pop back. Okay. And again, I'm printing the entire vector. By the way, you might have seen in the vector I've used v dot size. So v dot size is again a convenient function because the size of the vector keeps changing. So you cannot write n over here because maybe you have changed the size of the vector. So it is recommended you can write v dot size. So it will give you the current size of the vector and you can then access the elements just like an array. Very similar. Okay, let's run the code.
Gunjan, a new line. You forgot a new line after the second.
Okay. Okay, so again, yeah, you might have seen that the last 0 got removed because I have done pop back. Pop back means just remove the last element. Okay, and then there was one more v dot clear. So v dot clear just cleans up the entire vector. It removes all the elements from the vector. Okay, so suppose I want to now print the size of the vector. So I'll say size vector and then v dot size. Line here as well. And then run it. So now the size of the vector has become 0 because clear does what? It cleans, it removes all the elements and makes it an empty vector. So this is useful when you have multiple test cases or anything you might see, but these are the functions that we use. First is the pushback function. Pushback is used to add a value to the end. Then you can use insert, they can use pop back and then clear. So these are the main common functions that we use for a vector. Okay, so now we'll write a simple code. So suppose this is more what you will see in a competitive programming environment. So what will happen is first line will generally give you the number of inputs. So here first line will give n and the n lines will give the value for the element. What we have to do, our first task is read all the n elements into a vector and then we will sort that vector and then we will print that vector. Okay, so let us try this. Create a new file.
Gunjan, sorry to interrupt, but some people didn't understand the insert part right. If you could insert in the middle of the vector, they'd have a better idea, I think.
Sure. Sorry about the background. Yeah, so let us do v dot begin plus 3. Okay, and now again I want to print the vector. So let me print it again. Okay, so now what we are doing, again I'm going over the flow, creating a new vector. Okay, then making the first element as 5 so that we can see the first element is 5, then printing the new vector after after replacing the first element. Okay, this is replacement. Now we are inserting. So we want to insert a new value which is 1 at which position? At the third position. So the beginning will give me the address of the first location and then I will add 3. So 1, 2, 3. Okay, so we'll add at the third position. Let's see if that works. And yeah, let's run it. So initially we see that this is my first vector. Okay, which is as usual. Now I've inserted v dot begin plus 3. So now what v dot begin does is gives me a pointer to the first element. Okay, to the first element. Now if I add a 1, that will go to the second element. If I add a 2, it will go to the third element. If I add a 3, it will go to the, so you can see it is 3 yahan. Okay, it is at this position. So at this position, okay, it will try to insert 1. So I hope you understand v dot begin points at the beginning of the vector. So if you add a 1, now it has gone after the first element. If you add a 2, it has gone after the second element. Okay, and if you add a 3, it has gone after the third element. So the new position it will be inserted is here. Okay, and you can see the rest of the remaining zeros are same. So no value has been replaced, only a new value has been added to the vector. If I do v dot begin, nothing there. So it will give me a position at the very first, at the starting of the vector. Okay, at the starting. So it will add there. If I want to add the second position, then I will do plus 1 because it will add after the first element. Okay, after the first element. So you can try this. Any more doubts in inserting?
I think it's clear, Gunjan. We can move on.
Okay, great. So yeah, so we're talking about sorting. Now, just to make it clear, sorting means arranging the values of an array either in ascending or descending order as the question demands. So let us go over the question again. Let me copy paste the question. Okay. So this is my question. Okay. So in the first line, I will have n. So let me declare a variable n. Okay. Then I will take that as an input in n, c in n. Then what does the question say? The next n lines contain values for I less than n. So there are n lines and I will have n values that I need to input. So since I'm using a vector, I will declare a vector of int data type v of n size. Okay, I hope this is clear. I could have also done v and then push back. That is also correct. So anything we can pick up. So I have a habit of doing it like this. Vn. Then we will create a loop. Int I equals 0, I less than n, I plus plus. Then we will insert to cin pi. Okay. So let me just explain this quickly. We have created indexes from 0 to n. Okay, 0 to n minus 1 actually. We cannot access the nth index. And then what we are doing is we are directly taking input into the vector. So we are taking input into that element of the vector. Okay, so this is now I have a vector which has n elements in it. Okay, so let me first print the vector itself. So this is my vector without sorting. This is my original vector. Now we are trying to sort the vector. So what we will use here is called selection sort. Selection sort is an algorithm which is the most intuitive. So first of all, if you think of sorting anything, the first thing that will come to your mind is selection sort. What is selection sort? See through the whole array, pick the minimum element, keep it at the front, then see the remaining array, find the minimum element, keep it at the second position, then again scan the array, find the third element, put it at the third position, and so on. So this is not the fastest, but this is the most intuitive algorithm that people use.
Gunjan,
Okay?
maybe you can show it like step by step and show sample input output also. So like it's understood what selection sort is.
So like in the code itself, I should print it at every step. That way.
No, I meant just show a dry run of like just take 4 elements and show a dry run.
Okay, got it. So suppose we have 3, 2, 1, 5. 3 to 1, 4, let's take it. So we have 3 to 1, 4 as the elements. Okay. Now, obviously my expected output care, my expected output is 1, 2, 3, 4. That is the sorted order. Okay. So now let's do a dry run. First of all, what I see is, okay, what was my step? I will go through the array and pick the minimum element. So I went from 3, first I saw 3, then I saw 2, 2 is the minimum. Then I saw 1, now 1 is the minimum. Then I saw 4, still 1 is the minimum. So I know that 1 is the smallest element of the array. What I will do is I will replace 1 with whatever element is there in the first position. Okay. So now after the first step, my array looks like, okay. Let me tweak up things a bit. Otherwise,
Take
it
the
will be sorted.
reverse. Take the reverse array.
4, 3, 2, 1.
Yeah.
Okay. So yeah, this is exactly opposite of what we want. So first what we will do, we will go through the array and pick the minimum element. What is my minimum element? It can be easily seen, it is 1. So I pick 1 and replace it with the first position. So first position is 4. So I will swap 1 and 4. So my array will look like 1, 3, 2, 4. Okay, this is after first step. Now, in second step, In second step, now I know that this first position is fixed. This is the minimum element. So now I will look for the remaining positions. Okay. So now I will start my search from here. I will start from the second position to the last position. Now again, I will find the minimum element. Now in these three elements, the minimum is obviously 2. So I will take 2 and replace it with the second position. So I will take the element 2 and put it in the second position. Okay. So now my array will look like 1, 2, 3, 4. Okay. So it gets sorted in this manner. So you can think of it more like how you would sort an array. If you were given 10 numbers and you have to sort them, what will you do? You'll find the minimum one, put it at the first position, then find the next minimum one, then put it there, then find the next and put it at the third position. So this is how selection sort works. Now let us try to write an algorithm.
भैया
हाँ
वो एक्सप्लेन कर सकते हो प्रोग्रामिंग?
which one?
यही प्रोग्राम जो कर रहे थे
ये वाला?
हाँ, फिर से एक्सप्लेन कर सकते हो?
हाँ, no problem. So suppose my input was, let me type this as an input. My input was 4321. So I have 4 elements.
क्या मेरा कहने का मतलब एक्चुअली ये है कि है ना, वो स्टार्टिंग से जो आपने कोडिंग किया ना, वही प्रोग्रामिंग वो एक्सप्लेन कर सकते हो? वही सीधा इंट मींस से
ये वाला, this one.
हाँ भैया.
Okay. देखो क्वेश्चन में क्या था कि फर्स्ट लाइन will give me the number of elements. So first I need to take that as input. I have created a new variable and I have taken that as input. Okay. Now next क्या बोला
अच्छा
गया
भैया, तो जैसे रनिंग करेंगे ना, फिर बाद में इनपुट को हम पहले हमेशा सिर्फ एक ही नंबर लेते हैं, वो सिर्फ एक ही नंबर नहीं, सीधा 4321 ऐसा डालना पड़ता है, राइट?
हाँ, तो मतलब जब तुम when you will do competitive programming you will see कि फिक्स नहीं होता ना. So हर क्वेश्चन में there are different number of elements that you can take as input. So obviously हर बार पहले बोला जाएगा कि how many numbers are there, कि टोटल कितना नंबर तुमको इनपुट लेना है. So that they will give you first and then they will give the input of the numbers.
ओके, तो इसके लिए आपने तो ऐसा रन होके हुए इनपुट को आपने 4321 दिया, राइट?
हाँ.
ओके, थैंक यू. फिर नेक्स्ट बता सकते हो?
हाँ, फिर उसके बाद वही हमने एक वेक्टर क्रिएट किया of the size n. Then simply like how you would take an input into an array, very similar to that. ठीक है, I have taken the input scene use करके at the ith position of the vector. Okay, so this is taking input for the n elements. I have stored them in a vector. Now this is just printing the vector. After I have taken the input, I'm just printing the vector once to see ki what are the elements. And here I'm explaining selection sort, ki what is selection sort and how does it work. So we will translate that here as well. पहले यहाँ पे देखते हैं, then we will come here and implement it in code. Okay, anybody has problem with the selection sort algorithm? Ki how does it work? Okay. So let us try to implement it. So first what we are doing, first we know ki which position we need to replace. I know ki at the first run, I need to replace the first position. Okay. So it makes sense to make a loop that will go from first position to the last position and replace elements one by one. Okay. So I have created a loop for int I equals to 0. Here, yeah. Int I equals to 0. I less than n minus 1, because I will not need to replace the last element, it will automatically get placed, and I plus plus. Okay, this is a loop that will, इसमें क्या होगा? It will store the position to be replaced. Okay, and then I will create another loop inside this loop. Okay, so I will create another loop int j is equal to. So now again come to the example. What we are doing in the first step, जब I was 0, I've started my search from this element. In the second step, when my I became 1, यहाँ पे I का value was 0. Okay, यहाँ पे I का value हो गया 1. So when I was 1, I have started my search from the second step. Okay, so it is clear कि the searching variable, ये जो j है, this is the variable that will look for the minimum one. So it will look for the minimum one. So that is why it has to be starting from I. I don't need to look for the variables from behind I. So suppose after 3 steps I have in some other question, ignore this question for now. In some other question I have 1, 2, 3 and then dot 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 some other elements. Okay. So if I am here after the third position, then I don't need to see these values. Why? Because they're already sorted. I don't need to see them again. So that is why I'm starting from I. Then I will move to where? I will move till n and j plus plus. So I will move till the last index. Now I need to find the minimum index, the variable which has the minimum index. So what I will do is I will create a new variable over here, calling it minimum index, which is I. Since we are starting the search from I have said ki abhi let the minimum be I, and then whenever I will find an element which is smaller than I, okay, whenever I come across an element which is smaller than I, smaller than AI or VI here, then I will replace the minimum index to that element. It will become clear when I write it. So now the minimum index stores the index of that element, which is the current smallest element. Okay. So what is my condition? My condition is, so if v of j is less than v of minimum index, matlab the current element is smaller than the stored minimum. If the current element is smaller than the stored minimum, what should I do? I should update the value. I should update the value of stored the minimum index to j, because now j is the smallest element. The jth element is the smallest element. So I'm writing that as a comment. Jth element is the smallest element now. Okay. So this is done. Now once this is done,
should it not be j equals I plus 1 as you're comparing with the next element?
Yeah, that will save one step of computation, but anyways, because yahan pe, if it is I, then obviously it will, this condition will be false and it will never go here. Yeah, you can do I plus 1, that will save one step. Okay. So now after this loop runs, what we have? Now we have the index of the smallest element. Okay. Now we have that index. So what can we try to do? Now we have to replace. Now comes the part of swapping. Yeah, I have this index. Now I have to swap with the ith element. Okay. So this is one way of how we do swapping. You can see over here, creating it. There are many ways to do swapping. Okay, many creative ways as well. So this is the simplest way. You create a temporary variable and I store the value of ith element. Okay. Now I will assign the value of ith element. I will now take the new value of the ith element, which is v min index. Okay. So I hope you can see what is going on here. The min index has the minimum value, jo abhi, which is the smallest value. Okay. Min index has the index of the smallest value. So I'm storing that smallest value in at the ith position, and jo original value tha at the ith position, I have stored that in a temporary variable. And now v min index, I will make it equal to temp. So you can have a mental run ki how this will work. Okay. So suppose I have I think I should run it and then show it to you.
Wait, Gunjan, like I have an analogy for this. Like when I was in school, this is how our teacher taught us this. If you have 2 cups of coffee, and you want to move the coffee from one cup to the other cup, how do you do it? Like you want to exchange the coffee in both the cups. So you can't just pour the coffee from one cup into the other cup and then try to pour it back, right? Because then it'll get mixed. So what you do is you take another cup, you pour the coffee from the first cup into the other cup. That cup is what we're calling temp here, the third cup that we have. That is a temporary cup. Then from the second cup, we pour it into the first cup, and we pour it from the temp into the second cup. So we have exchanged stuff, and basically nothing is left in temp in the end, right?
Great analogy. I think now this has made it more clear. We are keeping a new variable. Okay. So because you want to store the content somewhere before we can replace it. So that is why this is a way of swapping. So now the swap is complete. So now what has happened is, now the minimum index variable is now stored at the ith position, and now the array from 0 to I is sorted. So from 0 to I have the correct elements, but the rest of the elements are still not correct. So the loop will run again till this time, till these many times, and I will now again print the vector. Sorry if I refer it to an array as every time, because essentially vector is also a dynamic array. So
could you print it after every step so that people can see very clearly? Like
okay.
Print I and maybe I plus 1 and then the entire vector after every step. So it looks very clear.
Okay, sorry. So let me print out. Right. Okay, and then the vector at that position. Put 2 spaces. And then I'm printing the final one. Okay, so it should run if there are no bugs. So let us first give it some input on which it should run. So just a second, standard out. Yeah. So first we should give the number of elements. So let us give 5 elements for now. And it also says to give the 5 elements. So first we are given the number of elements. Now we have to give those 5 elements. So let us take any arbitrary elements. So I'm taking 20, 30, 10, 50 and 40. Okay, just a random order so that we can see more of the sorting going on. And then let's run it. Okay. So now we will go through it one by one. First, this is my initial array. This is without any sorting. This is my input. So I can see my input is correct. I have taken the input correctly. Everything works. Now I've gone inside this selection sort thing. Okay. Now, just a minute. I should also print the value of minimum index. Okay, so now look at this block. This block. So what happens is, this was my original array. Now in this, what I've done, my value of I is 0. Matlab I'm looking at the first position. I now want to keep the first position. Okay. So now I start a search from j equals to I plus 1. So I start a search from 1, index 1, up to 4, index 4. Okay. I'm talking in terms of index. So keep that in mind. So I'm starting from index 1 to index 4. And I saw key, you can obviously see here that 10 is the minimum element. In this range, 10 is the minimum element. So that is why, and the index of 10 is 2, 0, 1, 2. So that is why my minimum index is 2. And now what it has done is, it has replaced the element at the minimum index, that is 10, with the element at the first position, that is 20. So now my new array after this step looks like this: 10, 30, 20, 50, 40. Okay. So 10 and 20 are swapped. Now, second step. Now again, I have already fixed this element, so I don't need to see this element again. Now I can work on this second element. Okay, so my value of I is 1 for the second element. I will start a search in this area. I know key 20 is the smallest element over here. So minimum index is again 2. I will replace 20 and 30. Okay, I will swap them. So now 10 and 20 are the sorted elements. I don't need to look for them. 10, 20 are sorted. I now want to look for the third position. Ki yahan pe which one should come. And now luckily for us, this is the smallest element in itself. But anyways, it will try to compare it with all the elements and it will say ki 30 is the smallest element and it is at the correct position. So there is a swap going on, but you don't see because 30 is getting swapped by 30. So there was no swap there effectively. Okay. Then we know that these three are sorted. Now these three are sorted. Now only these two remain. So now what we do, we again look which is the smaller one. The smaller one is obviously 40. So we will take 40 and keep it and replace it over here. Okay, we will swap them. I have my final answer as 10, 20, 30, 40, 50. Now the algorithm terminates because my value of I has gone to 4. So has gone to 3. Okay, I is less than n minus 1. So my n was 5. So I should be less than 4. Okay, so I has run till here. I don't need to run it for the last element because if all the elements are sorted, it is obvious that the last element is also at the right position. So now my final answer is 10, 20, 30, 40, 50. So this is selection sort, and it is one of the easiest and the most intuitive sorting algorithms. There are many weird and very intelligent sorting algorithms that do a job much faster. This is a very slow algorithm. We will talk about how to see algorithm is slow or fast. These all things also we'll see in this lecture. But for now, if you have any doubts in how selection sort works or any of these blocks, it will be easier if you try to talk in this language so that I can also explain with a live example. Any doubts at all? Also, since I have written this here, I really expect everyone to write this on their own as well after the class, and probably more algorithms. I will share some links for more algorithms, for more sorting algorithms, and you can try to see how they work and see some visualizations. They're very fantastic. You might have seen some YouTube videos as well. So in which they sort the elements in different ways, and you can see the speed. You can really see how elements have different speeds over there. So yeah.
The main emphasis of this algorithm is not to be able to like see the entire technicalities and be able to code the. I think the main thing is to be able to understand how sorting works and should be able to swap. Like you need to understand the logic first. Don't try to memorize n minus 1 here, j plus I plus 1 there, and all that technicalities. If you understand the logic, you should be able to write the code down by yourself. You don't have to memorize anything of any sort. And like we will also be covering time complexity today, right? So have a basic question related to that. Like if there's no doubts on this explanation of selection sort, the question is how many times will the loop under the comment selection sort, like how many times will the inner loop run totally? Only the until only the selection sort inner loop will run how many times in total?
I can like create a variable in the inner loop and ask how many times it gets printed.
Yes. Just count it, just create a count variable outside and keep adding 1 every time the inner loop is executed. Yeah. Like you guys can take your time. I want the answer in terms of n, but for the first try, you can try it in terms of n is equal to 5. Then try to generalize it to a certain n.
Is it n plus 1 by 2?
We'll find out. Write in the comments. Let's see. I think we'll wait a minute or so for everyone else also to be able to write some answers. Let's see.
Okay. There are a few variations. Okay, then I think we have some answers. So
Yeah, you can go on and run it. Yeah.
The rest of the code is same. I've just created a count variable. I've added 1 to it every time the code runs and printed the value. Count comes up to be 10. Now let us put the value and see how we got it correct.
Change the value of n also, and yeah, like kind of make it 10 and show that the answer was right.
Like, didn't get you.
I meant is that like the formula might work by luck also sometimes, no? So just change the value of n to show that it is definitely right.
I take 7 and then I add 2 more elements, 80 and 90. So let's run it again. And see the count is 21. So from the formula that I see, n into n minus 1 by 2 seems the most correct one. Okay. And yeah, it was j equals to I plus 1. That is why it was n into n minus 1. Otherwise, it could have been n into n plus 1 by 2. Yeah, correct. And so how did you come to this? How did we see? It is very easy. It is just really just basic arithmetic. We can see when the value of I was 0, this inner loop ran for how many times? From 1 till n. So it ran for n minus 1 times. Okay, so let me just write it over here. So in the first iteration, how many times it ran? It ran for n minus 1 times. Then the value of I became 1. Okay, I became 1. So j became how much? J was 2. And it ran till n minus 1. Okay, so it ran for n minus 2 times. Then it ran for n minus 3 times, n minus 4 times, and then so on up till it ran for 0 time or possibly 1 time. Doesn't matter, 0 anyways doesn't add up. So yeah, so it ran for these many times. So this is a very easy sum, and I hope everyone remembers it. It is n. So this sum is equal to n into n minus 1 by 2. Okay, so this is the base for what we are going to discuss next. Because when we talk about time complexity, it is essential that you figure out how many times your algorithm is running. So this is a very crucial step. And those who got it wrong, if you have any doubts, anything. Okay. So this was selection sort. And yeah, please try to implement it yourself without seeing the code. Even if you run into some errors, use these cout statements, print stuff, and see key where is the error. Don't refer to a website and copy the code. So yeah, let's come back. So this was all the effort that we did to sort a vector, right? And now we'll see a hack. So the hack is STL. You just write these lines, sort vector v dot begin v dot end, and the vector gets sorted in its place itself. No algorithm, nothing to be done. And it uses the fastest sort, which is quick sort. So it uses that sorting algorithm. We don't need to go into detail of implementation right now, but yeah, this is why STL is helpful, right? Because you don't want to write all this code. Suppose you're working on a problem, and for that you want the array to be sorted. If you spend this much time writing the sorting algorithm, then your time will get wasted instead of thinking about the logic. So that is when these algorithms become useful. So this will sort the array in the ascending order. This will sort it in a descending order. Okay, and you can see the third type, this one. There's a third parameter. Here I'm using 2 parameters, which you can see are the pointers. So it says to the sort function that sort the array from here to here or from here to here. So that is why it will sort from first iterator to the second iterator. But if you have a third function, so sometimes what happens is we don't want to just sort on the basis of less than. Sometimes you want to sort key less than or equal to, or maybe other things. Suppose you might have 2 variables, okay? And we will talk about pair. What is a pair? So suppose you have a pair. In pair, what will happen? What happens? The first 2 variables are same, first 2 elements are same, then check for the second element. So these things can be done using a custom comparator. I'm not going into much details because they're not used often, but yeah, they are used sometimes to make your job easier. Otherwise, you will have to write a whole sorting algorithm for that. So it makes your job easier in that way. So you can read about them here. A link is given in the slides. And yeah, so this is how we can sort a vector. Very easy, just one liner. Now we'll talk about pairs. So vector was a data structure that we discussed, an efficient version of an array, you can say. Okay, array with more functions. Pair, why do we need a pair even? So pair is used to store two variables together. Okay, so suppose you have a grid and you have the x and y coordinates. So ideally you will want to store the coordinates together for a point. So there is where coordinates are useful. You can also store the value and index and then sort it and then find out where the original number was. And maybe it is useful over there. Or you can even store different types. So suppose you have a name and the marks for a person. So you can store that in a pair. First one will be a string, second one will be an int. So you can create a pair with this code. Pair int, pair string int, pair double int, anything you can write. Pair p. Okay. So this is a pair and this one makes a pair. So this is the one that creates a pair, initializes a pair, and this makes a pair. So let us write it and see. And I have also, yeah, I've written the code over here. Just put it in the IDE. So pairs. First of all, we'll talk about what is a pair. Again, pair is just a collection of two items, nothing more fancy about that. Two items. You can reference the first element using pair.first, second.pair.second. Very easy. Okay, so let us come to selection sort. I'll let it be there. Just replacing this one. Okay. What have I done here? I have created a pair at the beginning. This is a pair that has a string and an int, and I've named it myPair1. And this is a function called makePair. So in recent versions of C++, you can also use a curly brace like this to create a pair. In older versions, this makePair was used. Anything is feasible, anything you can use. Okay, so it will make a pair which has the first value of this string and the second as 1, 2, 3. So you can call the first value using myPair1.first and myPair1.second. So let us just try to put it. The code. Okay, so what have I done? In the first step, this is my initial pair. I've just printed out the first and second elements one by one, first value and second value. Then we can also edit the elements of the pair. So after initializing, you can always edit the elements. So I've now made it the new value and then again printed, gets printed correctly. Fine. Now I can also create a pair in this way using curly braces, which is more convenient and shorter. So I can use this also to make a pair. You can also create a vector of pairs. So any doubts in this code? Then I'll show how to create a vector of pairs.
Where can you explain it once again?
Okay, so what is a pair? Pair is a collection of two items, nothing more, as the name suggests. Okay, the two items can be of different data types, also of the same data type also. And you can call the first element. Just say you want to know which is the first element of my pair. So you can use pair name dot first. So dot first will give you the first element. Dot second will give you the second element. Very simple. Then you can edit the values. You can change the values. That is all possible over here. And also you can create a pair in this way. So this is the older way of creating a pair using this function make pair. But now you can also use this curly braces to create a pair. And then I just shown it works by printing the values of the two elements. Ideally, this is not a helpful scenario where you are using it. Ideally, you will use it when you will want to store the coordinates, most probably, or you will want to store the value and the index. So sometimes the question asks you that sort a vector and then find out how many positions has an element moved. So suppose initially it was at the third position, but after sorting it has gone to the fifth position. So what was the difference? So these all questions might be asked. So in that cases, you will use a pair. So you will sort the first element and then you will use the pair to see what was its initial index and now subtract it from the current index. Just some examples where pair can be useful. You can also create a vector of pairs. So what I was saying is vector pair int, and let us call it a grid. Okay, so what is this? This is the vector which contains pairs. So this is, so suppose I give as input, suppose I have 3 points. First point has x coordinate 1, y coordinate 1. Second point has x coordinate 2, y coordinate 3. And third point has x coordinate 4 and y coordinate 5. Okay, so I can write a simple code for this. So I'll say for first, again, as usual, I will declare a variable that will take the number of elements int n, and then I'll take the input c in n. Okay, now for int I equals 0, I less than n, I plus plus. Okay, now what I have to do? I have to make a pair. I'm making a temporary pair int point. I've just given it a name of point. What will I do? I'll take the inputs. So c in point dot first, point dot second. I hope you have gotten familiar with taking inputs like this. So if there are two inputs in a single line, you can do it like this. C in point dot first. First value will go into the first one. Second will go into the second one. Okay, and then you can push this. So grid dot push back point. So what happens is a new point is being created. You have taken the two values into that point, and you're now pushing that point back to the grid. Okay, so at each step, the grid will have one more element. So this is an example of how you can push back and insert as well. Last time I did using the index, you can also push back. So this is one place where it can be useful. If I just try to print it out. So similar, and I don't have to do this. I can simply reference that pair from index grid I see out.
Your point is a pointer, right?
No, point is a temporary variable. You can consider like a variable.
Okay, the name of the pair is point.
Yeah.
Okay.
So just running it to see what happens. As expected, I have my 3 pairs, and all those 3 pairs get printed. You can see I have indexed the ith pair using this grid I. So that is why vector is just a container. In that container, you can store any type of any data type. You can even store more vectors in that data type. So it is just a container. Okay, so this is pairs. Now coming to tuples. Tuple is similar to a pair, except you can have more than 2 elements. So you can have n number of elements. So suppose you want to store how many fruits or the marks of a person. So you can create a tuple named Gunjan and then store the marks for all the courses. You can create a tuple named Siddharth and store the marks for all the courses. So in those places, it is not much used really in CP. Like I have never used it in a problem. So yeah, but just a good thing to know in case you run into something where you need to store multiple values for one particular person or one particular index. So this can be useful in that place. And very similar to a pair. Okay, just declare it with tuple, and then when you want to insert a value, then make tuple ABCD and then insert the value there. Okay. So this was the discussion all about data structures, because these are the data structures that are most frequently used. There are others as well, like sets, like map. So these are a bit more complex data structures, and at the very beginning you will not require them. And if you do require, so obviously there are websites like CPP Reference, Geeks for Geeks, where you can go up and read about them. So we cannot obviously cover everything, but these are the most important things that were required. Vector and pair are the most common ones. Tuple is still relatively unused. Map is also used when you will want to make dictionaries or something like that. But again, I will encourage you to take a look into it yourself and learn about the different functions and how it is made, how it works, what is the time complexity. Okay, time complexity. So let us look into time complexity. So in competitive programming, algorithms not only need to be correct, but they need to be efficient as well. Suppose you have a task, but your code takes hours to run it. So that code is as good as not solving the problem, because you want to have a code that solves it efficiently in a short amount of time. So that is why in competitive programming, a big factor is time. So first of all, obviously your code should give the correct answers. And second, it should give the correct answers in a distant amount of time. It should give the correct answers in a fixed time. Okay. So that is the place where time complexity comes in, that we'll need to calculate. Suppose I'm running this algorithm like selection sort. How much time will it take? Should I apply selection sort or should I apply some other sort? Should I use other types of algorithms? So this is where time complexity comes in. Okay. So we'll take a large overview. We'll go take a broad view. We will not go into the very details and the mathematical aspects of this time complexity. Okay. There are many things, and we really recommend you to go and look at the mathematical proofs as well on how to derive time complexity. But for our purpose, only building an intuition key, it is n square or n cube or all those things, that will be enough for now. But again, we really recommend you to look into the theoretical aspect as well. So let us consider a problem to understand why time complexity is important. Okay, so suppose you have an English dictionary, almost everyone has. So now if I tell you to search for a word brilliant, maybe, so what would be your approach? So the ones who know about what I'm going on here in the direction, so please refrain from spoiling it. Okay, so just think, what would the most natural approach? What you will take? So for many people who are relatively unaware of these algorithms, or of course, especially for children, so what happens is they take this approach. They check the first word. No, it is not brilliant. They will move to the second word. No, it is not brilliant. Third word, not brilliant. They will keep doing this until they come across a word which is brilliant, and they will say, yeah, I have got brilliant. So that is how someone naive or someone who is not aware of proper algorithmic techniques may think about. Okay, but since we are here to learn algorithms and make our code efficient, I should ask this question: is this efficient? Like it is. If I want to find apple, for example, it will be very easy because apple will come in very fast in the dictionary in the word of A. So is it efficient? Should I use this approach? Or there might be a second approach as well. So what can be that second approach? So I'll come back to this later. The second approach can be this. So what happens is when you take a dictionary, now this is what the people generally do. So what we do is we take the dictionary, we take out a random page number, or we take perhaps a middle page, and we see, okay, the middle page suppose has the word magic. Okay, suppose has the word magic. So I know since it is alphabetical, I know brilliant will always come before magic. So I don't need to check for the dictionary after the word magic. So I can simply tear off the dictionary, or for keeping it, you can just ignore that dictionary. Okay. So once you come across the word magic, you can ignore the later half and just focus on the first half of the dictionary. Okay. So now you will come to the first half. Now again, you will do the same thing. You will open the middle page or the first half and then see which word it has. So suppose the word is cat. So if the word is a cat, so you know again brilliant comes before cat. So what you will do, you will again ignore the later half, and now your dictionary size has gone from, suppose first it was 1000 pages. So after you remove the second half, it has become 500 pages. Now again you removed one half, it has become 250 pages. Okay, and now again you will open the middle page. Okay, now you can see this is an iterative algorithm. You are doing something again and again until you get the answer. So this is what we are doing. Take out the middle page with the remaining dictionary and see which word it has. Okay, see the word on the page. If the word comes after brilliant, like cat, so ignore that half. You can ignore the second half. Else ignore the earlier half. If the word is suppose apple, so if the word that comes is apple, okay, so you can so you know if you have opened that word apple, so you know the words before apple make no sense because brilliant comes after apple. So you can ignore the earlier half. Okay, and if the page itself has brilliant, very good, you can just say I have found the word brilliant. So this is an approach which most of us might take when you are looking for something in a dictionary or in a place where things are in order, that we tend to remove the choices. We don't want to go through one by one. We tend to remove the choices. So this is the second approach, which has been given the name binary search. Okay, and this first approach, since we are going in a linear way, we are checking one word, then the next, then the next, then the next. This is called a linear search. And now talking more as computer scientists. So if we see here that this is an array and we want to find out where is 33 in this array. Okay, so you can see in this animation, it first compares with 10, then 14, then 19, then 26, 27, 31, 33. It found 33, the algorithm exited. Okay, so this is how linear search works. Very easy to understand. Just check each and every element. If it is equal, great, we are exiting there. But this is binary search, and as you might have seen, it is not so easy. Okay, although the idea is very ingenious, that why would you take the later half when you know the word lies in the first half? Just simply ignore the later half. So at each time we are cutting down the size of our set by 2, cut it down by 2 again, cut it down by 2 again. So we cut the set by 2 by half every time. So this is called binary search. And now I'm just taking to a simple visualization for this. So suppose this is an array. Okay, you can see an array over here. Yeah, so this is an array, and let us take a number which is present in the array. Let us search. Okay, where does that element lie? So suppose we take 28. Okay, I want to search for 28 in this array. Okay, so let us take one step. What binary search does? Again, I will take the middle element. Okay, middle element kitna hai? Middle element is 50. Now I know that 28 is not equal to 50, obviously, but I know 28 is less than 50. So I can simply ignore this half. ये जो greater half है from 51 to 83, I know कि 28 cannot lie there. So I will look at this half. Okay. So again, I have ignored. Now this, I will never come to this part again. I will never come to this part again. I'm now looking only in this half. Okay. In the second step, I again took the middle of this half. So I'm looking in this half. I took the middle of this half, that is 36. So again, 36 is not equal to 28. So I will say 28 is less than 36. So I can ignore these three elements as well, because I know that these were less than 50 and greater than 36. So 28 cannot come here. So I will ignore these elements as well. So now all of these elements are ignored and I have to check only these 4 elements. Okay. So again, what my binary search will do, again, I'll take a step. So in this 4 element, not 4 exactly, 3 elements, because 36 is obviously not equal to 28. So in this 3 elements, again, binary search will pick out the minimum element, the middle element, sorry, the middle element, and then it will check. So is 28 equal to 22, which is no. Then it will say that 28 is larger than 22. So 28 should lie somewhere on the left. It should lie somewhere on the right of 22. I hope you are with me here. What we have done, first compared it with 50. We said 28 was smaller. Then we were looking in this side. Then we compared with 36. We said that no, 28 is again smaller. Then again we look here. We see 22. Now we say 28 is larger than 22. So we have these index. We have only one index remaining. Okay. So we have only one index remaining. Now we check that index. Yes, 28 is equal to 28. We found the key. Suppose I was looking for something like 29. So 29, I would have looked at this last index. I saw that 29 is not there. Then I will conclude that the element is not in the array. Okay. So this is how binary search works. You can see at every step I have broken my code into half. So my array into half. So initially it has these many elements 1, 2, 3, 4, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So 16 elements. Initially I checked this element and then broke it into a half of 8. Then I checked this element, broke it into a half of 4. Then I broke this. Then I checked this and broke it into a half of 2. And then 1 finally. Okay, so this is how binary search works. Okay. So now I want answers. So we have looked at 2 types of algorithms, linear search and binary search. So I wanted to think, if you're already aware, I'm please saying to the ones who are already knowing, please refrain from answering if you already know the answer. The ones who have seen binary search for the first time in their lives, please try to come up and say how many steps in the worst case. So suppose I had this array, which was essentially worst case. So again, I'll go back to that website. Where was it? Yeah, here. So in this 16 elements array, how many times will I maximum check for an element? How many times will my code run for the maximum times? Like in the worst case, suppose the element is not present only. Suppose the element is not present in the array. So how many times will my binary search run in that case? And how many times will my linear search run in that case? So same array, same key. Okay, I'm running two algorithms. So you need to tell me how many times linear search will run and how many times binary search will run. Okay, you can give me a general answer or maybe just a idea. Okay, then we'll come to these questions as well. So first I want the answer to these two questions, and especially who have seen these for the first time. Okay, whoever is still in the lecture, please write. If you have never seen this before, then do write. If you have seen this and you're not writing, I really appreciate that. Okay, so there are a few answers. Okay, so n in linear search, I think it is very clear why n in linear search, because obviously linear search is, it suggests the maximum you will check for each and every element. So what is the big deal? N times you will check in the maximum case. So great on doing that. Okay, now let us look at binary search. So in binary search, what we are doing at every step, I'm cutting down the array by half. So first I had n elements. Okay, then I had n by 2 elements, then I had n by 4 elements, then I had n by 16 elements until I have only one element remaining. Okay, so how many steps will I take? Think it in this manner. How many steps will I take? So how many times will I be cutting the array till I get to 1? Think like this. If you have an array of size n, how many times can you divide it by 2 till you get to 1? Those who answered n by 2 or root n for binary search, I'm specifically talking to you. So you can think it of in this manner. You have an n elements. You want to divide it again and again by 2 until you have just one element remaining. So now can you tell me how many times the binary search runs? Yes, log 2n, log n to the base 2. Okay, why? Because very easy to see. If you have 16 elements, first time you will break, you will get 8. Second time you will break, you will have 4. Third time you will break, you will have 2. And the fourth time you will break, you will have 1. So how many times it ran? It ran 4 times. What is 4? 4 is log 16 to the base 2. Okay, so it makes sense, I hope. If the value is not an exact power of 2, suppose your question might be, what if I have 10 elements? What will happen in that case? So not a problem. If you have 10 elements, then what will happen is one half will be larger than the other half. So one will have 4 elements, one will have 6 elements. Okay, so that is not a problem. So when we have these type of cases, we can obviously add more. We can make it a power of 2 in 2 halves. So we can do that. So if suppose you have 10 elements, then what we will do? 10 elements, then 5 elements. Then we need to take this half. So either we will take the 2 elements half or the 3 elements half, anyone. If we take the 2, then we go to 1. If we take 3, then again we go to 2, and then again we'll go to 1. Okay. So I hope it is clear. Now another question for you. Which one is more efficient? So we have talked about the worst case and also the best case, because best case is obviously linear search. It can find the element at the first step itself. Key first element is the key and you have got your answer. In binary search also, you can do it in one step. You take the middle element and that itself is the key. So in the best case, both of them take one step. So which one is more efficient? Which one would you like to use again and again if you want to write a fast code? Linear search or binary search? Yes, binary, because it is visible, right? That linear search for 16 elements you're running 16 times. For binary search you're running only 4 times, which is a great difference. So this efficiency that we're talking about, we'll write it in a formal way. Okay. Now the question comes, will binary search work if the array is non-sorted? So here, this animation, you can see the elements are sorted from 4 to 83. But will it work? Will binary search work if I have non-sorted elements? If I have 4, 36, 22, 28 in any order, will it work in that case? And the ones writing no, just write a small, like one line. Why would it not work? A small one liner. Great. Yeah, exactly. You cannot ignore a half. So any element can be present anywhere. You cannot ignore a half in that way. So that is why we need a sorted array. And that is why if you look at the overall complexity, then linear search is faster, because to sort an algorithm, you will take some time, and then you will do a binary search. So in that way, linear search can be fast. But in general, we always try to use binary search because it is much faster, and generally we work with sorted arrays. So even if an array is non-sorted, we might need to sort it in some way or the other to solve that problem. So that is why binary search is the one commonly used. And yeah, the efficiency of binary search becomes less when we need to sort an array. So first you will sort an array and then you will search on it. So binary search becomes more expensive in that case. But still binary search is the preferred one, and it is used very much to find answers, and in CP very much. You will rarely see linear search being used. Binary search is the way to go. Now coming to big O notation. So we have been talking about this efficiency. Now we need to write something which you and I can talk about in efficiency. You cannot say that the code takes 2 seconds to run in my computer, so it is efficient. No, because somebody else might have a faster computer, might have 16 cores or 8 cores or 2 cores, dual core computer. So we cannot quantify the time taken as a measure. Algorithm is fast or slow. Okay, we cannot do that. Also, one thing is that the input differs. So now I've talked about 16 elements. What if I give 1000 elements? Obviously 1000 elements will take more time than 16 elements. But I cannot say that 16 elements took 2 seconds, so 1000 elements will take these many seconds. That is not correct. So there is a notation called big O notation. What is this? This is basically how we represent algorithms. We talk about how much time an algorithm takes, how much space an algorithm takes. That is represented in big O. There's generally a estimate. Okay, we are talking about estimate here. In the worst case, what happens in the worst case scenario? There are measures for best case and the average case as well. But generally we look at the worst case because obviously our worst case should run within the time limit. We don't need to worry about the best case. If the worst case is running in the time limit, best case will obviously run in the time limit. So we need to look at the worst case scenario. Okay. So talking about big O, what is big O? Don't get afraid if you are seeing this for the first time. It is just a set. Okay. So O of n is a set. O of n is a set of all algorithms that are of the form of this. Okay. So if your algorithm takes 7n steps, your input size is n. Okay, your input size is n, and your algorithm takes 7n steps, then your algorithm belongs to O of n. Okay, take a minute to digest this. If your algorithm takes 7n steps, then your algorithm belongs to O of n, because we don't really worry about the constant, because the value of n gets so large. When we're talking about O of n, we talk for values of n very big, so big values that the constants rarely make a difference. Okay, so 100n or 7n or 8n or 2n are all equivalent to O of n. Okay, so that is why this notation is very useful, because you can group algorithms together. That these are the fast algorithms, these are the slow algorithms. This is where this comes in useful. And So this is the first part. You have to ignore the constants. So 7n is same as n in this notation. Okay, 7n is equals to 8n is equals to n is equals to 100n, similar. Then we have a notation of domination. So certain terms tend to dominate over others. Like n cube is obviously greater than n square. Now this might be not true. You know that this is not true for values between 0 and 1. But whenever we are talking about O of n, we are looking at very, very large values. And that is arbitrary. We don't know what is that exact value, but we are looking for such large values that this one clearly dominates over n square. You know that for values of very great values like 10,000 or 20,000, n cube will be much, much greater than n square. So that is why we can write this as a dominating factor. Then n square is greater than n log n. You can easily see that on a graph. You can use Desmos and Prot graphs. I will even show you a graph right now. Then there is n. Okay, so n is obviously smaller than n log n, and log n is a positive quantity. Again, we are talking for large numbers, so this is a positive quantity. Then root n. Okay, so also there is a tendency to ignore the lower. So now we talk ki n cube will dominate over n square. So what if my algorithm takes n cube steps and then takes 7n square steps? So it takes these many steps in total. First n cube steps and then 7n square steps. Then we will classify it as O of n cube. We will ignore this n square. We will take the highest, we will take the most dominating term basically. So this is the most dominating term. So we'll take this over here and then we will give the algorithm as O of n cube. Okay. This is a cheat sheet. You can refer to it for the time complexities of different algorithms, different operations. You can do that. Let's look at this picture. So this is the Biko complexity chart courtesy to that website. So we are seeing this is why time complexity is important, because you see the value of n elements is the value of n. So n is increasing in the x-axis and operations on the y-axis. So you can see key examples like O of n. O of n is somewhere here. Okay, in this fair region, yellow region is the fair region. But you see for O of n square. So suppose your algorithm takes n square steps. So as the value of n increases, the algorithm explodes. You can see the algorithm takes a very large amount of time. And even more time if you have an exponential algorithm. If an algorithm takes 2 power n steps for each step, then you can see for even small values of n, this thing will blow up and dominate over all others. Okay, then n factorial is obviously the worst case you can make. So n factorial is the worst case you can make. And it is almost like a very, very bad algorithm. The generally good algorithms or the ones we use in CP are of the order of O of n log n, O of n, O of n root n, O of root n. Okay, so don't get confused by this O. O is just a notation. You need to look at the content inside. This means that the algorithm takes n log n steps in the worst case. In the worst case, it takes n log n steps, and it is a fairly good algorithm. And what is this O of 1? Does O of 1 means it takes only one step? So let's talk about that. O of 1. O of 1 means constant time. So it means that the algorithm does not need to take any step. Matlab, it will always give you an answer in a constant time. Okay. So suppose I have this operation. I have 75 into something, and then y is equals to a, then s into y. So I don't need the answer here. I'm just saying that these values are all computed. I don't need to calculate these values. I don't need to run anything. I just need to do plus multiply. And these algorithms are independent of the input size. So if I take 75 or if I take 10,000, it is assumed that they take similar amount of time. Okay. So that is why these kind of operation like adding and multiplying, subtracting, or even accessing the array. So if you access the array, suppose ARR 0, ARR 1, ARR 2. So these also take O of 1 time. These take constant time. Okay. So this is what constant time mean. And this is the best complexity your algorithm can have. Okay. So O of 1 is the best complexity that your algorithm gives an answer irrespective of the size. So one very simple example is finding if a number is even or odd. Okay. So I give you a number and you have to tell whether it is even or odd. So you don't need to do anything. You just take the remainder by 2. If it is 1, then it is odd. If it is 0, then it is even. So this is a constant time algorithm. You don't need to solve. Don't need to have any steps. Okay. So this is about big O notation. Any doubts you can unmute and ask, please. We will look at some examples. That is what I'm saying. If you have any doubts, you can unmute and ask. Feel. And yeah, this part is important because whenever you're writing an algorithm, if you have solved some questions, you might have run into an error called time limit exceeded. So that is a direct relation with this big O complexity. That you're taking more time than expected. The problem wants you to take less time. So you will have to write a more faster algorithm, a more optimized algorithm. So that is why in CP, only characters of matter, you have to write the efficient algorithm as well. Okay. I don't see any doubts. If you want to unmute and you can ask.
Yes, O of n linear search does fall under O of n. The one thing you need to consider is this graph here is generally, this is talking about how an algorithm scales with the increasing amount of data. So what that means is, if today you have, let's say, a processor that can process X amount of operations in 1 second, now, and you have Y amount of data. Next 2 years, if the data is doubling and the processing power is also being doubled, you should still take a similar amount of time, right? Now, if you have an n square algorithm, if the data doubles, you will require 4 times more processing power to be able to do the same thing in the same amount of time. So in that way, this just talks about the scaling of an algorithm, and it's not generally giving you a truth about whether an algorithm is really good, because a linear search is in general a very naive algorithm, and a binary search is a much better alternative. But yeah, that's pretty much it.
Okay. No doubts, I think. Okay. Then, since you have no doubts, I'm posing some questions for you. So very simple ones. We will start with the easier ones and then move further. Just look at this piece of code and tell me the time complexity. If you're not still familiar with O and stuff, you can just write whatever you feel like. Okay, how many times this code runs? The question, whenever you're asked time complexity, it means how many steps are taken in solving this problem. So yeah, go ahead and tell your answers in the chat. You can recall that when I said plus is a constant time algorithm. So plus takes a constant time. So plus is not, you will not say key like plus takes extra time. Okay. So first of all, I will see your answers and then explain in that way. So feel free to say your answers. You can also say how many times it runs, or you can give the big O notation. Anything works.
No. I think at this point we need to stop considering how many times it runs and talk about stuff in a big O notation only, because in the end it doesn't matter if it's running n-1 or n times, because it'll approximately take the same amount of time, right?
Yeah. All right.
And n into O of 1 is not true.
Don't write it like that. And okay, yeah, just give me the big O notation. And from big O notation, you will also see key n-1 and n+1 are not really different when you go into very large values of n. So n-1 and n+1 won't make a difference at all. Okay. So whenever you're talking about big O, we're talking for some very, very large values where these minor differences of multiplying by a constant or adding or subtracting 5, 10, 1, anything like that, these things don't matter at all. Even n/2 and n are the same category. Okay. So if a function takes n/2 time, then it also belongs to O of n, because n is multiplied by a constant half, and that half does not matter in the long run. So if you take a very, very large number, it will be very close to n. O of n/2, a function with n/2 line will be very close to n for a large value. But they don't differ that much. Okay, so we see that the answers are there. O of n. Yes, indeed it takes O of n because it runs how many times? So suppose it runs, like you can see this loop here, it will run from 1 to less than n. So it will run from 1 to n minus 1. Okay. So how many times it runs? The loop runs for n minus 1 times. Okay, n minus 1 time. And in each step of the loop, I'm doing one operation which takes constant time. Okay. This operation takes how much time? It takes a constant time. So as one of you pointed out, it is n into of 1. So we don't write it like that. It is not essentially something can be multiplied, because as I said, O of something is a set of all functions. So when you study more theory, you can see it cannot be multiplied like that. But what you can conclude from that is that, yeah, a step which is taking constant time is being run n times. Okay. So if it takes one time, then this entire code will take this entire code will take 1 into n time. Okay. And that is why the complexity for this code is O of n. Okay, I hope everybody understood. We don't worry about n minus 1 or n plus 1. We don't worry about 2n or 3n. And we also don't worry about the additional time it takes to increase I. Okay, because that is a constant time operation. So O of n will obviously dominate over 1. O of n dominates over 1 in the long run. So we say it is O of n. Any doubts, you can please unmute and ask at any point now. So we'll move forward, but if you have any doubt while I'm explaining, you can ask. Okay, so another example. How much time does this take? Quick answers. Give me the big O notation. O of n squared. And it is correct, right? The outer loop, we have seen this earlier. The outer loop, this will run n times, and whenever this runs once, then the inner loop will run n times. So it will run n plus n plus n plus n plus n. How many times? N times. So n into n is n square. So this entire thing takes n square units to run. Okay, this entire block takes n square units. This code takes n time, and this n time code has been run n more times. So it has become n square. Great. Now another example. Be careful, I've written int j equals to I over here. So how much time will this take? And I think this is familiar to you because we discussed something like this in selection sort itself, something similar. So what is the time complexity for this one? O of n squared. Okay. So if you recall, the answers we got then was n into n minus 1 by 2. But now as I see in the chat, everybody is writing O of n square. So why has that changed? Because we know that n into n minus 1 by 2 is what? N square minus n by 2. I will remove the constant, so I will get rid of the divided by 2. I have n square minus n. Okay. I know that n square will dominate over n. So I will ignore the n as well, and I have only n square remaining. That is why I'm saying the complexity is O of n square. So I hope now you have understood how you can take out the time complexity from simple arithmetic. So you applied arithmetic to tell how many times it ran, and from that you have derived the time complexity. Just ignore the constants, ignore the lower order term, just keep the highest order term. Okay, that is your time complexity. So great. Another one. So look at the question carefully. There are two loops. This is the first loop and this is a nested loop. So what is the time complexity for this one? Think about it. You can answer at your own pace. Comparison, addition, or accessing an element, these all take constant time, which is O of 1. So you can ignore that. Do we have answers? Okay, O of n square. Great. Now, why is it O of n square? So because we have seen these examples separately, and I've just combined them. So I know that this block of code, this part, this upper loop, takes n steps. Okay, this takes n steps, or O of n, and sorry. So this takes O of n, and this lower loop, this nested loop, takes O of n square. Now I know ki n square will obviously dominate over n. Okay, so I don't need to write O of n square plus n. That is not allowed. You will just take the leading term, the most dominating term. So I know ki n square will obviously dominate over this O of n. So my final complexity is O of n square. If anybody has any doubt at this point, please unmute and ask, because this is important. Your code will generally have more than one loop and more than one types of statements. So you will need to figure out a time complexity. So any doubts, then please ask.
Bhaiya, can you explain the time complexity of the last question? The previous question.
This one.
Yes, this one.
Okay. So see, we have seen this कि यहाँ पे देखो j का वैल्यू क्या है? J starts with I. Okay. So initially I was 1. So j will start from 1 and j will run till how many times? Till less than n. So पहले बार में कितना चला? First time the j will run from 1 to n minus 1. Okay. So it will run n minus 1 time. Just keep it in your mind. It will run first time for n minus 1 times. Then secondly, I will become 2. When I became 2, j will become 2. Then j will run from 2 to n minus 1. So that is how many steps? That is n minus 2 steps. Okay. Then again from 3 to n, that is n minus 3 steps. Then again dot 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 until it will run for only one step, that is from n minus 1 to n, and it will finish. The loop will finish after that. Okay. So how many times it ran? N minus 1 plus n minus 2 plus n minus 3 up to 1. And from basic class 12th mathematics, you must be obviously knowing ki the sum is from 1 to n minus 1 is equal to n into n minus 1 by 2. So that is the total number of steps in which it ran. Okay. So that is the number of steps. But what we want a time complexity. So we know ki we can ignore the constant. So n into n minus 1 by 2 jo tha, we can simply remove the divided by 2. We have n square minus n. Okay. Then वो n square minus n में I said कि n square is dominating. N square has a larger value. So suppose you take very large values of n, 10,000, 20,000, anything like that. So you know कि n square will be much greater than n. So n square will dominate over n, and we will say that the overall time complexity is O of n square. Okay. Remove the constants, remove the lower order term, only the higher order term should remain, and that is our time complexity. Is it clear?
Yes, Bhaiya. Thank you.
No problem. And if you have ever any doubt in time complexity, just like we did in the previous one, write a count variable and increase it every time in the loop, and then print it at the last. So you will see ki total kitta hua, and you can get a rough idea of how many times or what relation it might have. Okay. So this was about time complexity. Now, why is it relevant to us? Because when you do programming, the first thing you need to do is optimize your code. And in competitive programming, the questions usually assume that the computer can do 10 to the power 8 operations per second. Okay, 10 to the power 8 operations per second. So if the question says that you have that the value of n, that the input size is less than or equal to 10 to the power 5, and the time limit is 2 seconds. So your code can run for 2 seconds at the maximum. So I want you to tell me what complexity algorithm can you use? Give me a rough idea. I don't need the exact log values. Give me a rough idea of the common graphs that we saw in this slide. Just a minute. So from these algorithms, tell me which one can you use when the question says that the input size is less than 10 to the power 5 and the time limit is 2 seconds. So give me an idea of which algorithms you can use. I want the highest one. Yeah, you can obviously use O of 1 and O of root n as well. I want the highest time complexity algorithm that you can use. No, you cannot use O of n cube because n cube will blow up. N cube is 10 to the power 15 and your computer can do only 10 to the power 8 operations in 1 second. So in 2 seconds, how much? 2 into 10 to the power 8. So should not exceed that. So n log n, generally we use that it as the benchmark. So we use n log n or faster algorithm. So n log n, n root n, these all can be used. And but yeah, you cannot use n cube at all. Even n square will give you a TLE. You cannot use n square. Generally, we use n log n. But suppose the problem is smaller. Suppose the value of n is less than 1000. Then in that case, that O of n cube becomes feasible because now let me see, O of n cube. No, O of n cube is still not feasible. You can use O of n square over here because if you use O of n square, that will become 10 to the power 6 operations, and that is less than 10 to the power 8 operations. So that is how you will see your algorithm will pass or not. Instead of trial and error, should first write on a piece of paper that how much time your code takes, how much the problem allows, and does your code run within that time limit. Okay. So this is what we had for this lecture. First, we talked about STL, vectors, pairs, selection sort, and then we talked about the general time complexity of different algorithms. Any doubts you can feel free to ask.
In the previous slide, can you just open it once? In the second statement, if we use n cube, it will be 10 raised to the power 15. So why not begin?
But your computer can do only 10 to the power 8 seconds, 10 to the power 8 operations in 1 second. And the question says you have 2 seconds. So I think you are squaring it. You will have to multiply it by 2. So the total operations that you can do is 2 into 10 to the power 8.
So an n cubed algorithm in this case would take 10 power 7 seconds approximately to give an answer. And yeah, so you can see that an n log n algorithm or an O of n algorithm is of the order of 10 power 8 or 10 power 10 faster. So that is why a better algorithm is important, right?
We'll share the slides later on. And if there are no more doubts, then we can end the session. Thank you for attending. And yeah, please practice the problems that we had given in the previous one. And now you can move on to HackerRank and even give Codeforces contest, the starters. Starters contests are very good for someone who is beginning programming. So give starters and you can solve the problems. Thank you for attending.